Tutorial 2 question 1. Okay, it's a unidirectional laminate. Alright, we have a unidirectional laminate that runs at a certain angle, 45 degrees. When the laminate, so this laminate itself, it's only 45 degrees. That's all. Alright, there's no other degrees. Okay, and was tested under maximum static design loading. Alright, so once you test it, alright, you will have certain strain, as you can see. So this is in the x direction, in the y direction, and in the xy direction. Alright, so I repeat again, your laminate, alright, will be over here. Okay, and you'll have a certain angle like this. Okay, because it's going 45 degrees. Alright, 45 degrees. So therefore, your laminate is being pulled in this direction, in the x direction and in the y direction, and there is a certain strain. Alright, this particular strain is over here, strain x. Alright, it is okay. So in fact, what they are doing is actually pulling in this direction. Okay, because it's a positive value. Alright, so when they pull, this strain is 0.1% of its original so-called original length. Okay, and then there will be a compression at the x direction, so this thing is going to be compressed a little bit. Alright, so therefore it's something like that. So this particular strain is 0.4%. Okay, and I will believe that this 0.4% takes in account for both directions, two directions. So this thing and this thing add up together is 0.4%. Alright, same thing, 0.1% is this side and this side up together, it gives you 0.1%, alright, of the strain. And there will be a certain so-called shear strain, alright, which is 0.2%, trying to shear it. Alright, trying to shear it. And that's the so-called the understanding of the question itself. Alright, so we'll start by doing the question A first. Alright, question B we will not do it because the lecturer haven't go through. So the question A asks us to determine the factor of safety for this particular laminate. Alright, against this stress failure using the TSAI HILL failure theory. Alright, so the TSAI HILL failure theory is something that we have gone through in the previous parts of the videos. It's in 6.4, video 6.4, there is explanations over there. Alright, but nonetheless, the TSAI HILL theory is used to so-called derive your factors of safety. Okay, and therefore how do you start by doing things? Alright, you are given the strain. Definitely you need to have something else. Alright, since we are not doing part B, let's cancel this off first. Okay, in the exam questions, luckily they actually provided you all these understandings. Okay, so they give you this particular stiffness matrix. The values has been found for you. This is a stiffness matrix. Okay, this is in fact your Q bar. I think it's Q, I forgot already. This is in fact your reduced stiffness matrix Qij. Okay, so it's your strain, alright, and this is the stress in the 1-2 direction. Okay, so therefore this is your Q. So they actually find for you your Q instead of giving you all the parameters, asking you to find individually their values. So they have provided you this thing. Okay, so once you have this thing, then it's much easier for you to apply. Alright, so I'll put it over here. This is the thing. Alright, so we have this strain X, strain Y, and gamma XY. Right? However, if you think about it, this one is 1-2 direction. Alright, this is in the X direction, and therefore you cannot straight away sub it in. You don't sub it in here into here. Don't do that, you'll kill yourself. Okay, so what you're gonna do, come back here. Alright, this is the bottom part. There is another equation. Alright, to help you find your strain 1-2. Okay, so you have your strain XY, so you can just simply do what you want already. Okay, so I also need this formula. Okay, so in order to get this, okay, our final purpose, our objective is to find this thing. Okay, is to find this value after we add them up together. Okay, and in order to find this value, what we need is actually your stress value. okay, which is stress 1 and stress 2. Also your shear stress 1, 2. So therefore what we need is this thing. However, this thing is not provided to you, alright, because the provided to you is in terms of xy, not 1, 2. So this is why we need this one. And therefore our first step is to find this one first, then second step find this one, third step find this one. Okay? Such, the first step that we have been doing, alright, I repeat again, this is in terms of xy direction. Okay, so graphically maybe it is clearer. So the string given is only given in this direction. Okay, however, what we want to calculate for the stress in the 1, 2 direction using the TSAI HILL failure is talking about the stress in this direction. We're actually keen to look at this direction, not this direction. Okay, hopefully this is very clear. Alright, this is why we want to transform first. This part over here is to transform xy into 1, 2, and then we sub it in over here to find the stress, and then you sub it in into the TSAI HILL theory to get your answer. That is it. Hopefully this is super ultra clear. So therefore, you just sub in your 45 degrees into here, alright, and then this is your strain x and strain y, you can just sub it in, alright. What we have is this matrix over here, okay. So over here I just simply subbing in my 45 degrees, straightforward, very straightforward, but make sure that when you sub it in, ensure you are in the degree mode, not the radian mode, okay. So over here is a bit tricky, so be careful when you sub in the values, alright. So they are in terms of a certain percentage, alright, they are in terms of a percentage. It is minus 0.4%. Percent, if you change to certain decimal, is divided by 100, and this is why we have 0.004, okay, which is this one. Alright, be very careful when you change to percentage, okay. It's really divided by 100. So if I work it out, if matrix, alright, is row times column, and then row times column, row times column. So the first row times this column will give us the first value, which is our epsilon 1. Okay, so in other words, alright, I'll do up this first part first. Okay, so 0.5 times this one, alright, plus this one times this one, plus this one times this one. Hopefully this is very clear. Alright, so what you have when you do up the matrix, okay, I'll not go on the details, but you just need to know that when you do matrix multiplication, this one times this one plus is addition, this one plus this one plus this one times this one. Okay, so what I will have, maybe I should write down. Based on this matrix, I've calculated all this, at least there are some things in mind. Okay, and that some kind of mistakes over here, but should be fine. So let's fill it in. So minus 0.0045. Maybe I should go in and zoom in a little. 0.0045. Okay, for epsilon 2. And for this one, remember, is a half gamma 1, 2. So if you want the gamma, let me see. So half, I think we'll just leave it as half gamma 1, 2. No. We want gamma 1, 2, okay, because over here they are using gamma 1, 2, as you can see, okay. So therefore I have to multiply in. So this one half I'll bring it over. So this one will becomes, so gamma 1, 2 will become equals to 0.003. Yeah. Okay. So we have 0.003. Alright. So this thing over here is epsilon 1, epsilon 2, and gamma 1, 2, which is for this value, or nonetheless this one. Okay. Actually, it should be for this one. Okay. So they are in terms of 0.0000 something. So let's make it easier type of thing. Since we don't need all this, alright, I'll just simply shift all this formula down a little bit. Alright, at least it's easier for us to take a look. Okay. So this one we don't need already. So let's take a look on this. Alright, how do we simplify it in terms of SI unit? Alright. So 1, 2, 3. So I have 0.5. 1, 2, 3. I will have 4.5. and 1 2 3 I'll have 3, okay, and to times 10 to the power of negative 3, okay, and therefore I can also put this away, alright, since I've shifted all the things and it is to our needs, alright. So this is the part over here. So this one over here is this one. Alright, next I gotta find this one. Same thing, I use row times column, row times column, row times column, where we have found all this, we have found this column, this is this. Okay, so if you were to multiply, what you should get, I will not go through the details already. Alright, you should get these values. Alright, and in fact, the lecturer's one, his values are different. Alright, and his one is 65. Actually his one is minus, and this one is 20. Alright, so there is some discrepancies here and there. I should also take note of this minus. Okay, so if I take note of this minus, yeah, you give me a while. Alright, I'll just need to add in the negative sign, that's all. Okay, so our stresses are all this, and think about it, they are actually in terms of a MPa. Alright, so this is another trick question type of thing, because in the given question, alright, they actually give you this your Q, alright, as a times 10 to the power of 3, alright, but they didn't give you the SI unit. Alright, but if you were to refer back to the previous section, alright, this thing over here, they are all in terms of MPa, alright, megapascal, and you should oneself remember that all of the composite definitely they are in terms of gigapascal. Okay, so therefore in this case, if this is in gigapascal and if the rest are in terms of megapascal, then you should bring, so for example, actually this is MPa, alright, this whole thing is in, I should say that this part over here is megapascal. Okay, if times this one, this whole thing is gigapascal. Okay, so this is how they write things. Alright, and why they write things in terms of this is because they want to suit this thing, MPa. They are all MPa. Later on we're going to use them. Alright, so therefore these are the things that you should take note of the SI unit. So once you know that they are in terms of MPa now, alright, we have these stresses, then we can finally sub it into this equation. Alright, it's really simply sub it in, nothing's fancy all about. So I'll just crop this picture out, and therefore we can just simply sub it in now. So we know our sigma 1, sigma 1, sigma 2, and shear 1, 2. The only thing that we do not know is x, y, and s, and this is why I copy it over here, because it's also given. So your x is 600 MPa, your y is, let me see, this is where the trick comes in. Alright, so they actually tell you the x, y, and s, alright, in terms of 1000, 60, and 50. Alright, and these are the strength in their laminar direction. So it's talking about the strength when you are pulling the laminar. So if the laminar is over here, this is the pulling direction. Alright, however, if so, also given that x is equals to 600 MPa for compression. Alright, so x is different in different way of things. Over here, these values, alright, maybe I should use a different color. These values are all for when you pull. Alright, this value is when you compress. Okay, and you should use the compressed value. Why? If you take a look back, alright, our question tells us that when you pull, your y direction is extending by 0.1%. It is increasing by 0.1%, the strain. Alright, but however, the x direction is being compressed. Alright, and this is why you should take note that when you use your x, please use the correct x value. And this is why you are using the 600 MPa. Okay, please be careful. So I'll just sub in all these values in terms, and also these values. So I'll only sub in for this one is for y, this one is for the s value you're shearing, this one is for x when x is being compressed, y is the one that you are pulling in that particular direction. So when I sub in, I'll just sub in all of these values. Okay, and these are the things that I sub it in. You can double check yourself. So if I were to calculate for all this, I got this value, alright, which is also different from the lecturers. This one is actually 2.05. Alright, I don't know how it gets, but somewhat this is the answer for or this is the method, I should say. This is the method of approaching this type of question. Alright, so you will know what type of equations you will need to use and things like that. So you should actually check it out. Alright, and make sure that you kind of know what the things. So your purpose is to find this one, and since you know that you want to find this one, you need to first find your stress one, and you know your values x, y, and s. So x, y, and s is given in the question, so you need to find sigma 1 and sigma 2, which is using this equation. Alright, and by using this equation, you need the strain in the 1, 2 direction, and this is why you need this equation, because 1, 2 direction, because what they are given is x and y, the strain. So you need to convert into here, and then this one you sub it in, you get this one you sub it in. Sorry, I'm lagging. Alright, but you get this one, and then you just get all this. You should get the values. Alright, but nonetheless, I may be wrong. So, and highly the chance that I will be wrong, because it's very small of a factor. But anyway, so this is it. So in the next video, after he go through, then I think I'll just update the answers, and we'll continue with part B. There's a part B question also. Alright, so yeah, yeah.